Hi. Hi,
Hello,
how are you?
doing well. How are you?
I'm fine, thank you. So we are lean now. Can we start?
Sure, yeah.
Okay. Okay, welcome to NJS the Meetups, where we gather today to explore the latest. Okay, 1 minute. Okay. Okay, again. Welcome to the NJ Asia Meetup, where we gather today to explore the latest trends and advancement in Angular, a powerful framework for building dynamic web application. We are honored to have with us a prominent figure in Angular community, Minko Gechev, who is currently serving as engineering product lead at Google. Today, we have a privilege of diving deeper into one of the most exciting topics in the Angular world, Angular Signal. Angular Signal is a concept of gained significant attention recently, and Minko Gechev is at the forefront of exploring its potential as a in a today meetups. We have a privilege of hearing directly from Minko Gechev himself as he delves into a fascinating world of Angular Signal. We will explore the concept, its implications for web application development, and how it can improve us to build a faster and a more efficient Angular application. So you can start.
All right. I will need some permissions to share my screen. If you
Yeah,
can
sure.
enable that.
Yeah, okay. Can you try again?
Yeah, let me do that. Hear us. All right. Perfect. Do you see my screen now?
Yeah.
All right. Yeah, thank you for having me today. I decided to expand the scope a little bit of the presentation because in version 16 we introduced signals, which is, as you mentioned, a major feature. We refactored the entire reactivity model of the framework, but we also shipped quite a few other things. So I'd like to discuss them, and at the end of the presentation, we can pick whoever is interested in signals. We can dig a little bit deeper into this concept, and we can explore signals, computed, and effects, and how they impact Angular change detection. All right. Angular is Google's framework that is a default recommendation for development of web apps. There are main frameworks that we have at Google. Some of them are specifically focused on mobile. Some of them are cross-platform, such as Flutter. And Angular is specialized in development of web apps, even though you can build some mobile experiences with it as well. At our team, we're very much evidence-driven. So we decide what to include in Angular based on data. And this data could be collected from different sources: developer surveys, conversations with developers, meetups, as the one today. If you have some feedback about Angular and how you'd like to use it, we can incorporate this in our roadmap, and so on and so forth. But probably one of the main resources that we're using, this is the Angular developer survey. It has been giving us a lot of information about how we can evolve the framework to make it better for everyone. And one of the things that we kept hearing again and again is how to make it simpler. So in version 15, we shipped standalone components, standalone APIs, which allow you to simplify your application from something like this to something like this. So we're dropping concepts and code significantly just by dropping ng modules and providing an alternative approach to import your components directly in the component metadata. They were creating quite a lot of conceptual overhead over the years with stuff such as figuring out the difference between ng modules and JavaScript modules. So I bet most developers are not going to miss them too much. Something new that we shipped in version 16, this has been the schematics for transforming your application to ng module-based application to stand alone. It goes through 3 different steps. First of all, it tries to migrate all your components to stand alone. After that, removes redundant ng modules once you move from importing ng modules to importing your component metadata. And last, it also can update the component, the bootstrap of your application. So in this case, we can see how ng generate Angular core standalone is going to completely remove the app module. It is going to update our components to standalone, and it is also going to update the bootstrap process to use bootstrap application rather than bootstrap module from the first example here. Another thing is the opportunities to build new applications by using standalone APIs. So now you can just run ng new my application -- standalone, and this is going to generate way simpler directory structure. So it is going to look something similar to the directory structure on the right, where we have way fewer files, which are way easier to comprehend from by beginners. But as you mentioned during the introduction, the most impactful, I'd say, feature has been reactivity. With reactivity, we mean the process of updating, reflecting changes in the data model to the view. So here, when we're typing, we're triggering some, like adding additional symbols to this text box and triggering some validation logic in Angular, for example. This is an example of reactivity. We're reacting to the user input. Angular has been using Zone.js for reactivity for a while, where we have been waiting for the microtask queue of the browser to get empty, and once the microtask queue is empty, we run change detection in the entire component tree. And we wanted to improve this for 2 reasons. First of all, Zone.js is not very much aligned with modern browser APIs. We can't plug into the microtask browser queue without down-leveling async await to promises. So this has been a blocker for us. We still need to down-level async awaits to promises in order to make this properly work. And the second challenge is that we're performing change detection in the entire component tree, even though only parts of the component tree has been updated. So what we decided to do is to assign projects to rethink the reactivity in Angular with more fresh, new perspective, and decide what would be the future direction of this reactivity model, which would be the reactivity model that fits the best the component model of Angular and also the development paradigms that we have been using. Our team looked into a variety of different ways that modern frameworks approach the problem. One of them was just making the Angular compiler, taking it one step further so that it can understand the dependencies between the view model and the view itself, similar to Svelte, let's say, where we generate some code that is going to invalidate properties once we update them. That was a valid approach, but we decided that it might not be the best fit for Angular because it creates some compile time magic, which sometimes can be unintuitive at runtime, especially when you're building more complicated experiences. We also considered using proxies. Why not wrap every single property in your Angular components that you have bounds to with a proxy? Well, this also was a little bit too magical because sometimes when we're editing, let's say, arrays, the proxies can have some unpredictable effects. For example, they expose some low-level implementation details of array methods. We also considered hooks, similarly to React, but they didn't really fit the fine-grained reactivity model that we were aiming for. So we ended up moving forward with signals. And signals expose 3 primitives to allow you to build reactive experiences. They expose the signal. This is a function that allows you to wrap your values and enables you to read the values and also set them. That's pretty much it. It is just a value that you can set and read. It also adds the primitive for computed signals, which allows you to read signals within a function. And whenever any of the signals read within this function changes, we mark the computed signal as dirty or needed to be recomputed if we read it again. And we also added effect. Effect is a function that would get run every time when the signals within this function change. All right, these are the 3 primitives. I know They might not be obvious right now with me just talking about them. So it's the end of the presentation. If you're interested, we can write some code. What we liked about signals is that they provide reactivity everywhere within your application. So you can have signals within your components, but also you can have them within your directives, services, or pretty much anywhere. So they're a pretty flexible reactivity primitive. This doesn't mean that you should keep them anywhere, because this could create a little bit more complications in the trying to figure out the data flow, but they provide a lot of flexibility. They also enable precision updates. What I mean by this is that we don't have to rerun change detection in the entire component tree as we used to do with Zone.js. Now we will be able to be way more intentional. When you have signal and you're using it in one place in your component tree, what we're going to do is detect when the signal changes, and we're going to go to the component tree and only rerun change detection in a small portion of it. Not even in the entire template of this component. We're going to rerun it only in a fraction of this template called a view. And last but not least, signals are also a pretty lightweight dependency of the framework. They're only about 2 kilobytes gzipped and minified, maybe even less, depending on the implementation that they come up with. Another thing is the conceptual simplicity. I told you that there are just 3 reactivity primitives. A signal, which is just a value that you can read and set. Computed, which is just a value that you compute by using signals. And effect, which is just a function that gets re-executed once any of the signals it reads changes. They're a familiar concept. They provide you some way of moving, you just understand this core concept, and you can use it in a lot of other frameworks around. You can use it in Angular, but also you can use it in frameworks such as Preact or Solid.js. So you learn it once and you can learn it, you can use it everywhere. And also interoperability. It is critical for us to make sure that Angular is backward compatible. And also the existing reactivity model keeps working really well with signals. We designed the signals primitive in a way that you'll be able to move individual components to signals within your application and keep the majority of it in Zone.js if you'd like. So if you'd like to transition to signals from Zone.js, you can do it incrementally, but also you don't have to. Very much depends on your use case and your goals. Eventually, we're going to strongly recommend for new applications to get started with signals, but for existing applications, Zone.js is going to continue working in foreseeable future. All right. Another thing about signals is that I already mentioned that the framework is backward compatible, and we have been working with different framework authors, such as the folks from NGRX, NGXS. We received some feedback from Ben Lesh from RxJS on how we can improve the integration between signals and RxJS. And already NGRX, I saw some prototypes using signals. So we have been working with the ecosystem to ensure that all the existing tools and libraries out there are well implemented and integrated with signals. Yeah, that's the good news. Angular signals are in developer preview in version 16, which means that you can already start experimenting with them today. Developer preview though means that we can break this API every week because we release Angular every Wednesday. So next Wednesday, we may decide to change the implementation of signals. They're not stable right now. We haven't announced the API as public, or it's public. We haven't announced it as kind of stable, setting different guarantees on how we're going to evolve it. We're planning to do that in version 17. So now they're great for experimentation, and in version 17, you can already start adopting them gradually. So where are we moving signals from here? Well, first, it's going to be to make Zone.js optional. Zone.js is this library in Angular, which I'm sure you have used, that allows us to plug into the browser's event loop and invoke change detection when a particular event happens. In the current implementation, we're invoking change detection when the microtask queue of the browser is empty. We're going to enable local change detection I already mentioned this, but just to reiterate, rather than checking for changes the entire component tree, the signals are going to let us know where exactly a change happened so that we can check only a fraction of your component template. And also simplicity of the Angular's API. You don't have to think about expression has changed after it has been checked, for example, or just some unpredictable behavior of the change detection, because this is a little bit magical with this global monkey patching of Zone.js. And last but not least, as I mentioned, we'll be working on evolving the ecosystem. We're partnering with different state management libraries, and we are making sure that they have a path forward with signals. All right, this was the signals portion of the presentation. I'm going to continue talking about our build tool chain. So if you have more questions about signals, we can definitely chat about that in the end. We have about 43 more minutes in the presentation, so I'm sure we're going to have time. We have been talking about ES Build for over a year now, and we have been trying to change the internals of the Angular CLI to be using ES Build instead of Webpack. And we released a very early experiment in version 15. Now in version 16, there is ES Build in developer preview to power your ng build and ng serve, but we also incorporated Vite as part of the ng serve experience. It provides the development server for ng serve. We actually, some developers in the community already started using it. We saw 2.5x improvement of the build speed after switching to ES Build. There are some small bundle size regressions, like a few percent, but the build speed improvement is considerably faster. We're planning to completely change the build system of Angular CLI and replace Webpack with ES Build in version 17 if everything moves as planned. And in the meantime, we're also working on something called local compilation mode of the Angular compiler, which in development mode will enable us to compile individual files separately rather than having to maintain the dependency graph that is defined by the different selectors in the application. So this is going to speed up build speed significantly for development mode, and it is going to keep everything the way it is for production, and incorporating like more advanced techniques such as, let's say, disk caching or remote build execution with tools like NX is going to obviously like bring down the production builds as well. Now, looking at the developer survey results, I don't know if you noticed that at the beginning, but server-side rendering, testing, and debugging, they have been at the very bottom of the list. So there are a lot of opportunities for improvement. We already shared the improvements we did in stack traces with Chrome DevTools last year, where we're removing unnecessary parts of your stack trace that are coming from frameworks. And we're stitching stack traces that are coming from different async tasks, and also trying to also replace call frame names that are coming from your templates directly with the templates code rather than the generated code by the Ivy compiler. We're continuing to iterate on this. Chrome DevTools, I think they're going to make this view of the stack trace the default. And we also had a couple of brainstorming sessions with them to figure out how to improve debugging experience even further between Angular and Chrome DevTools. But another big news is that we're moving the Angular CLI to be using Jest. This has been already one of the popular solutions in the community, and there are a lot of fantastic tooling that has been built by the community, such as the Angular Jest preset. So we just wanted to leverage that. We wanted to meet developers where they are and wanted to provide you Jest as a default option as part of the Angular CLI. Angular on the server has been another big investment. I already talked about signals because like reactivity is our biggest investment in 2023. We're investing a lot into making the Angular framework more reactive with signals and making the reactivity fine-grained. But we also want to improve the load time performance of applications. So we have been investing a lot in server-side rendering as well. And we're doing that to make apps faster, because based on the Chrome user experience report, it turns out that just using server-side rendering for an application can improve the cumulative layout shift, which is the CLS metrics from Core Web Vitals for your applications with 40 times. So if you want to have a fast application that loads fast, quickly, server-side rendering is just a core requirement. And a very important part of the hydration of the, server-side rendering story when building apps is the hydration algorithm that the frameworks use. If I was able to see you, I was going to ask you how many of you know about hydration, but let us just dig into what hydration means now. So here we just have a laptop, which is, you can think about it as your machine. We have a web browser that is running on your laptop, and we have an application server that is running Node.js and a content delivery network here, CDN, that delivers static resources. When you want to open a web app, you're first going to go to the application server, to Node.js, which is going to run Angular on the server, and it is going to produce markup, some HTML. We're going to get that in the browser. And at this point, the Angular application is not going to be interactive, because it's just going to be static HTML and CSS. There are going to be some scripts that are referenced within your HTML. And these scripts need to be downloaded from the CDN so that we can make your application interactive. Once we download these scripts, we're finally going to make the app interactive. But so far, we have been making it interactive by completely re-rendering it from scratch, which sometimes has been causing this flickering that you can see. See, we render the app, and this quick flickering appears, which is suboptimal. It causes some layout shifts and sometimes can delay loading of large images, which can slow down some of your Core Web Vital metrics. For this purpose, we have been using the so-called destructive hydration, where we receive the DOM from the server, the HTML, the browser makes it, converts to DOM, and the framework re-renders the application by first destroying everything but the root of the application, and after that re-rendering it from scratch, which, as I mentioned, is pretty suboptimal because of the cumulative layout shift risks and also reducing the load speed for some large images. With hydration, what we're doing now is, rather than destroying your component tree, just traversing it, and at every point, kind of trying to figure out to which component does this current DOM element belongs to, so that we can build, we can hint Angular that this component tree already exists, and we just attach event listeners and build internal data structures rather than re-rendering everything. With hydration, we saw some improvements in the largest contentful paint of apps with up to 45%. And we made it available in version 16. So everything that you need to do there, you just add 2 lines of code to import with hydration and with client hydration, and just add this to your application configuration and boot up. There are some sample applications that I can show you later on. All right, yeah, in version 16, together with hydration, we also shipped quite a few quality of life improvements that I'm not going to dig too much into depth into, because I want to move towards the end so that we can discuss more signals in case you're interested. But some of them are just the directive composition API. Here, for example, we're applying the has_cover directive on the map menu, required inputs, which now allow you to specify which inputs you would like the framework to enforce that we have set value to at build time. New features in the Angular language service, and also functional router guards. This has been one of the features that has been reducing the complexity of the router significantly just by reusing the inject function. And another highly wanted feature, highly requested feature, has been passing router data as inputs. So now rather than you having to inject the router data token in your components, you can just use this particular feature of the router that is tree shakeable and pass the router data directly as inputs of the components that the router rendered. Content security policy support has been another feature that we recently shipped, and some improvements in the image directive that reduced that can allow you to improve your largest contentful pane for applications. So some of the new features that we shipped there are fill modes in developer preview. We have automatic generation of SRC sets, and also we backported this to version 12 and newer. If you haven't been using this ng optimized their image directive, I would strongly recommend you to do that by importing it from the common module and just changing your images to be using ng SRC rather than SRC. You're going to notice the effect of this almost instantly. And yeah, and with this, we shipped features in total with in total of like combined more than 2,500 thumbs up. So if you have favorite features that we haven't shipped yet, I would recommend you to go to github.com/angular/angular and find them and just give them some thumbs up. We really consider your feedback as part of the feature prioritization process. So from here, we'll be also investing a lot of time in the Angular material design implementation. It is currently the public reference implementation for Angular for Google Material Design for the web. And we're planning to ship Material 3 support later this year, potentially around version 17 timeframe. It is also going to contain way more flexible and expressive theming API, expose via SaaS. To inform our future decisions, what we'll be working on and shipping in version 17, we also looked at the developer survey results. Now, let me show you how you can read this chart. Here we have the importance score based on the feedback we received from developers in our annual survey. Based on their preference for the framework, we assigned an importance score for each one of these different products areas. And also performance score. Based on the feedback, we decided how satisfied developers are with the individual features. And based on the survey, it looks like we can further improve the documentation and sample codes. We can improve initial load time performance and component altering format together with testing. So we'll be investing into these couple of features in version 17. Specifically around component altering formats, we're going to explore improvements in the control flow. So I know we have ng4 and ngIf. We're going to continue having them, but also we're looking into how we can make them a little bit more JavaScript-like, how we can have ng-else that is more intuitive compared to what we have right now, and also how we can make it a little bit faster. If you have looked at the JavaScript performance benchmarks that are public by the community, Angular is doing pretty well, but we would like to do even better. And improvements in the control flow are going to allow us to do this. Also, we'll be continuing investing in the initial load time performance of applications. We're working on a new directive, I would say. It's going to be more than directive. It's going to be template syntax that is going to allow you to specify particular parts of your component tree and lazily load them. Angular is going to know when to load them lazily and how to hydrate them in case you have server-side rendered them. Well, these are some of the features that I wanted to share with you. I would like to spend the remaining 30 minutes with questions, just answering questions, because I know that the topic was specifically around signals, but I also wanted to share about everything else that has been happening in Angular. So let me know what you're interested in, and I'll be happy to chat about it.
Okay, we have a first question about from Adam Noor, and the question is, I want to know about the future of the Zone.js in Angular framework.
Yeah, well, every single Angular app, well, not every, but let's say 99.9% 99% of Angular applications right now are using Zone.js. And probably that's going to be the case 5-6 years from now, with more applications being created with signals. But Zone.js is still going to be a major part of the development of Angular apps. So yeah, we're just going to continue maintaining it and make sure that it is aligned with web standards as much as it can be. I mentioned already some of the disadvantages of using Zone.js right now around async await. We just can't patch async await in Zone.js, which doesn't allow us to plug into the event loop. So that's why we currently have to down level async awaits to promises. This is going to be the case also in the future. This is not something that developers need to worry about in any way, just because the Angular CLI knows when you're using Zone.js, and it performs this transformation just transparently for you.
Okay.
We're hoping that over time more and more people are going to start moving to signals, but Zone.js is going to be around.
Okay. So second question is from Adam, and it is I would like to ask about the future and the perspective of RxJS in Angular framework and using with the signals.
Yeah.
Yeah.
I have been seeing this messaging online that signals are here to replace RxJS, and they are not. They are very different concepts used for very different things. Like if you have a stream of events, let's say a WebSocket, and you have a bunch of messages being sent over this WebSocket, if you must be like, you should be using RxJS. Signals can't do anything about it. They're just like one value that is observable, and you can just set it, and you can get notified when this value has been changed. So they're very different concepts. Something that is helpful though is that with signals, we can translate signals to observables. And this is only possible because the signal is one value that can change over time. And RxJS works with values that change over time. So we can very easily notify an observable every time when the signal has been changed. And this would allow us to provide even better integration with RxJS. For example, we'll be able to have reactive inputs. That has been a very highly requested feature for many years. And I think I personally closed this issue a couple of months ago, or at least commented on it, just mentioning that we're planning to do it. Just give us some time, and changing the reactivity to signals enables that.
Okay. So, okay. The next question is from Murad. Is what do you think about the future of Angular signals and Angular services or NGRX for state management?
Yeah. I can't comment on NGRX actually, because I'm not part of the team there. We have been talking to the NGRX folks, specifically the framework team, and I know that they have some experiments with signals. Also, they don't really have to move to signals if they don't want to. RxJS is a completely valid option that you can use, and you'll be able to have better integration with Angular if you have a signal-based app. So I can't really comment on the future of NGRX. I see it as bright and not impacted by signals, but I don't know about their roadmap.
Yeah, okay. So with the questions, it's it. We have only this kind of the question on the live chat on YouTube now. So if you have some example to show, we can continue with them.
What example around using signals, or?
Yeah, maybe. Yeah.
Yeah, we can try to build an application together. I may have to. Let's see. We can build something simple. Do you see Stack Blitz here?
Yeah.
Perfect. Okay. Yeah, we have Angular. Let me zoom in a little. We have a version 16 application here. that's like with a standalone component and with the common module. So we can move this application to be using signals, let's say. What we need to do is import a signal and wrap the signal, wrap the Angular. Like, actually, let me go one step back. I'm sure you're all familiar with the with the simple like Angular getting started app, but let's just go through a few more details. Also, in the template here, we have binding to the name property in the app component. And the name property here is only a string. The way we're going to make this application signal-based is just wrapping this string into a signal. And you can see that now the header changes to hello from function something. This is just because name now is a function. In order to read its value, we need to invoke the function, and we're getting now the value of the signal, which is Angular. Now, if we would like to change this value, we can do something like that. We're going to invoke the set method, which is going to be something different. And I can add a click handler. And now when I click here, this is going to change the value to hello from Asia. So the way that things work in signals, let's say, actually, let's first make it like a Zone.js app. Like let's discuss how this is going to work with Zone.js. With Zone.js, this is going to work by this following way. Like with Zone.js, when I click on the button, when I click on the header here, what is going to happen is that the browser is going to schedule a new task that is the execution of this event handler. And Angular is going to plug into the microtask queue. So it is going to plug right after the execution of this task. And it is going to traverse the component tree. And in this case, the component tree is only this single component. And after that, Angular is going to check the template function, which in this case has only one binding to the name property. And this way, Angular will know to update the value of name because it's different. The way that it changes with signals is we now call a function. And I need to change the way I'm reading the function. Do you see how I'm calling the function right here? I'm calling this function right here, and this we kind of like we can think about it as an effect. Like, all right, let's see if I can show you Chrome DevTools and the generated code. It might be more interesting. Let me actually no need to do that. Let me actually like show you what Angular is going to generate. It's going to be something like this. It's going to be a component that has like a template function. And there are going to be two blocks. One of the blocks is going to be if creation, and the other one is going to be if update. And during creation, Angular is going to do something like that. Create element h1, create text node hello from, and it's going to have interpolate name context.name. And that's pretty much it. It knows how to close these elements. And on update, it is going to have something like that. No, actually, this is going to be directly context.name. And on creation is going to have something like that, interpolates context.name in some dynamic part. So this is just the Angular like template function. Ivy is going to generate this code right here. Not exactly this code, but a code that looks similar to this one from this template right here. And this is if we're not using signals. If we're using signals, this is going to change to a context name, and context is the instance of this class right here. It's going to change context name to context name function call. And it is going to do the exact same thing right here. Now, if you think about this template function, it looks very similar to the functions that we are passing to compute an effect in the signals world. So if we wrap this in effect, Angular would now know to invoke this template function when the signals within these template function change. So if context.name changes, Angular is going to know to invoke the template function and in update mode and the interpolation directive. So it is going to check whether name is different, and if name is different, it is going to go and directly update this text node here. Does that make sense at all, or should I?
Yeah.
Yeah, and effect is just a function that accepts a callback, which callback reads signals, and the effect callback is going to be executed when the values of these signals change. So I guess what I really enjoy about this particular implementation is that it is almost, I mean, it would not be using entirely public APIs, but it's almost is, because you can use effect outside of the code that Angular is generating by yourself. And I mean, it's going to have very similar semantics. Yeah, so this is a very simple signal-based application. We can also use one more abstraction here. Let's say we can add ng on init, and here we can use something called effect. And within this effect function, effect callback, we can load this .name. So now when I click here, in the ideal world, I'm supposed to be getting this name changed. Sometimes I may have to refresh my browser. Let's see if it's going to end up working. Oh, some problem with taglets now. Those taglets won't load. Or maybe we can create a new project and try it out again. What is it? ng on init, and let us implement the on init lifecycle hook. All right, yeah, so we can read we have to re-implement a lot of things. We can read the effect. We can read the signal in the effect. Oh, it's not in injection context. Sorry about that. My fault. Here we go. Yeah, now when I click on the signal on the header here, we're going to invoke the set method of the signal, which is going to trigger value change, which is going to execute the effect. And it must be within. So if I do this, it must be within the constructor. It must be within the injection context, because we would like to do automatic cleanup of the effect when the component is destroyed. And we can do this if we inject the destroy ref and add a callback to the destroy ref. So that's a constraint that we currently have, which is kind of intentional by design. Yeah, and the final abstraction that Signals provides is called computed. So we can have, let's say, something called full name, which is computed. And the full name could be, let's say, I don't know, this dot name, prefix name, let's call it prefix name, with certain prefix, I don't know, ng prefix. And these could be just different meetups. We can have Angular Asia, and we can have Angular Denmark, for instance. And what we can do here is bind to the computed value, and the computed value is going to be marked for recomputation only when the name value, the name signal changes. That's pretty much it. That's pretty much what signals are in Angular.
Okay, thank you very much. Yeah, we can finish. Okay, thank you very much for your time. And for example,
yeah. One thing to add only is some of the features that I talked about. For example, the local change detection, it is not currently happening. What I showed you with the template function and how we are potentially going to wrap it within a signal, that's not there yet. We're planning to ship this in version 17, but this is just currently a hypothetical thing, how it is potentially going to be working in version 17. And at the moment, change detection functions very much the same way that it used to with Zone.js. You can be just binding to signals directly with the signals library.
Okay, thank you very much. We will wait new updates from your team. And so thank you very much all. And we will end now. And thank you, Minko. Have a nice day. Thank you very much.
Thank you for having me. Bye.